Okay, so this is exercise 11F, question 13, a question that lots of us found a bit tricky when we're thinking about it for prep. First thing we've got to do is find what P and Q are using the information they've given us in the question. So from the question, because we've got a point of intersection, P plus 10x minus x squared must be equal to Qx plus 25. They've also told us some roots, or where the two intersections are. A is 4y and B is 8y. We don't know those values of y as yet. That is going to be important later on. We've got two ways that we can think about this first part to find P and Q. We can think about it with equating some coefficients between things that we know in the question, and we can think about it in simultaneous equation type way in a second as well. So thinking about it with equating some coefficients. Now if I've got P plus 10x minus x squared is equal to Qx plus 25, first thing I want to do is just get everything together on one side. So I've got a nice positive x squared instead of a negative x squared. I'm going to take everything over from the left hand side to the right hand side. So that's going to give me x squared. Now if we look at our x's, I've got a 10x and a qx. Because the 10x is going from the left hand side over to the right hand side, I'm going to have plus q minus 10x. And then similarly thinking about the numbers, I'll have 25 minus p. And that's of course now going to be equal to 0. Now because they've told me that these x coordinates are 4 and 8, I know that they're roots. So I can have x minus 4, x minus 8 is equal to 0. Now I know that that's not necessarily a full quadratic. The picture isn't a full quadratic at the moment, looking for the roots across the x-axis. But of course they are the points of intersection, so the values have to be the same for both equations, so it's similar to a quadratic in that way. So if we equate what's going on, if we look at what's going on, to get that 25 minus p, I'm going to do minus 4 multiplied by minus 8. So the value of 25 minus p has to be the same as minus 4 multiplied by minus 8. Similarly, to get that q minus 10x, I'm going to do x times minus 8, and I'm going to do minus 4 times x. And then of course the two x's here and here will multiply together to give me the x squared. So thinking about the number first, 25 minus p has to equal minus 4 times minus 8. So 25 minus p is equal to 32. Now to make that true, p has to equal minus 7. And that's what it asks us in the question to prove. So we've shown that p is equal to minus 7. Similarly, q minus 10 has to equal minus 4 minus 8. Because if we were to multiply that out, we'd get minus 4x minus 8x. So q minus 10 is equal to minus 12. So q is minus 2. So we can find q and p using that method, using equating coefficients. The trick, of course, is to recognise that this is true and how we can equate it to what we've got over here. We have got another method though that we can use. We can think about a simultaneous equation type way of doing it by substituting these values of x into the equations. So if I've got p plus 10x minus x squared, we know that p plus 10 times 4 minus 4 squared is equal to 4q plus 25. So multiplying all of that out and working it all through, we eventually get to p plus 24 is equal to 4q plus 25. So p is equal to 4q plus 1 by subtracting the 24 from both sides. So we know that p is the same as whatever 4q minus plus 1 is. That's used x is 4. Let's do the same process with x is 8. So p plus 10 times 8 minus 8 squared is equal to 8q plus 25. Again, multiplying that through, we'll get p plus 16 is equal to 8q plus 25. So p is equal to 8q plus 9. So we've got two equations that are quite easy for us to work with now, and two unknowns. So thinking about normal simultaneous equation type ways of working, in fact we don't even need simultaneous equations because they're both equal to p. So we can just eliminate p straight away. We get 8q plus 9 is equal to 4q plus 1. So minus 8 is equal to 4q. By of course subtracting 4q from both sides and then subtracting 9 from both sides. So q is minus 2. Now if we know that q is minus 2, if we substitute that back in, we can start working with p. So p we've got already is 4 lots of q plus 1. So p is minus 7 as required. So two different methods there for finding the values of p and q. From there we can quite easily do the rest of the question. In part b we know that the coordinates of a is 4y and b is 8y. B is 8y. So we need to work out the values of y there. And we certainly need to know what the y is, because the whole question is going to rely on us knowing what that line is, because we're going to need curve takeaway line in a minute. So if a is 4y, when x equals 4, y is equal to minus 7, because of course we know now that p is minus 7, plus 10 times 4 minus 4 squared, so y is 17. So a is 417. Now, what we've already been working with is this point here, this point of intersection. But in order to find our bounds for the integration, we need to know what that intersection there is as well. Now thinking back to our original equation, we've got minus x squared plus 10x minus 7. Just to make life easier, I'm going to multiply through by is equal, of course now we know, to 17. But to make life easier for myself, I'm just going to get a positive x squared. So x squared minus x squared minus 10x plus 7 is equal to minus 17. So x squared minus 10x plus 24 is equal to 0. And if we factorise that, we get x minus 6, x minus 4 is equal to 0. Now of course we already knew that one of the roots was 4, but we've now got our second root. So this intersection point is 6, 17. And of course once we've got our points there of 4 and 6, for those 2 points we can easily work out the integration now. So the line AC is y equals 17. That's there, y equals 17, and we know that the curve is x squared minus 10x plus 24. So we've got curve takeaway lines between 6 and 4. So it's going to be minus 7 plus 10x minus x squared. Of course it doesn't matter what order we write any of this in. Minus 17 because we're taking away the line, all with respect to x. That's going to work through to the integral between 6 and 4 of minus x squared. I'm just rearranging it to make it all easy now because I didn't write it in the best order. Plus 10x minus 24 dx, which of course will give me minus x cubed over 3 plus 5x squared minus 24x between 6 and 4. And when you substitute everything in, of course in the exam you need to now use the curved brackets to do this, but I'm running out of space. When you do all that, it comes to minus 36 plus 112 thirds, which comes to 4 thirds overall. So we had a few different ways of finding the initial P and Q at the beginning. I think it was all about noticing what's happening with those intersections, and then of course when we get to the integral at the end, recognising it's a curved takeaway line. I hope that all makes sense and is helpful. Thank you.